This is Half Past Paper Week 14, higher tier, non-calculator, and we're doing all the even numbers this week. So odd numbers were last week, so if you want the rest of this paper, go back and watch week 13. This is week 14. Off we go. So starting with multiplying mixed fractions, question number 2. Show that 2 1/3 times 3 3/4 equals 8 3/4. So when I show that question, you don't want to use the answer. We're going to do this and show that we get the same answer from our working. Okay, so 2 1/3 times 3 3/4. Let's start by making both of those fractions top heavy. To do that, you're going to do the big number times the bottom number, add on the top. Big times bottom, add on the top. Okay, two holes and an extra third. Remember, each of those holes is 3/3. So you've got 2 lots of 3 and an extra 1. So big times bottom, add on the top. 2 times 3 is 6, add the 1 is 7/3. Times, and again here we're going to do big times bottom, add on the top. 3 times 4 is 12, add the 3 is 15/4. Now when we times fractions, we actually don't need to make the denominators the same. When you add and subtract fractions, you do need to make them the same. But when you're timesing, you do not need to make them the same. You can just multiply across. So 7 times 15, let's just do that over here. 15 times 7. Now 7 times 5 is 35. 7 times 1 is 7. Add the 3 is 10. So 105 divided by 12. And then we just need to think, how many times does that go in? Just write out your 12 times table if you're not sure. 12, 24, 36, 48, 60. 72, 84, 96, and then it would be 108, which is too big. So 1, 2, 3, 4, 5, 6, 7, 8. So it goes in 8 whole times with 9 left over out of 12. I've got that 9 because I've gone from 96 up to 105 is an extra 9. Now we're almost there, but this fraction does simplify, and so this becomes 8 3/4 because both these numbers are in the 3 times table. So we can simplify it down. There we go. We've shown that we get the same answer that they do, and that is 3 marks. Question number 23. The diagram shows 4 triangles. 2 of these triangles are congruent. Now, congruent means the exact same shape and size. It might be rotated, reflected, but ultimately, if you cut them both out, they would fit exactly on top of each other. So 2 of the triangles are congruent. Which 2? Which 2 of these triangles are exactly the same? Now, as a bit of a clue, if you look here, 10, the angle that it's opposite, remember angles in a triangle add up to 180. I've got 45 and I've got 55, which adds up to 100. So in this first triangle, the 10 is opposite the angle that's 80 degrees. So I need to find that where it happens again. In triangle C, 10 is opposite 55, so that's no good. In this one, 10 is opposite 45, so that's no good. And in triangle D, 10 is opposite 80. So it's going to be this one and this one that are the same. They are just turned round. So triangle A and triangle D are congruent. They are exactly the same triangles, just in a slightly different orientation. Question number 25. ADC is a triangle. AED, so that's this line here, is a straight line. And ABC is a straight line. That's that one there. EB is parallel to DC. We can see that from the little arrows. Angle EBC is 148, which is labelled on there for us. And angle ADC is 63. Work out the size of angle EAB. EAB is that one up there. If you go from E to A to B, the angle that is formed is that angle at the top. So that's what we're looking for. I'm going to pop an X there so we know that's what we're working out. You must give a reason for each stage you're working. Now, as an examiner, it's easiest for us to see the reason if you write it and you label the angles as you go. So the first one I'm going to say, I know that this angle is 63 degrees. Why do I know that? Well, looking at these parallel lines, I can make that F shape. And so that is corresponding angles are equal is the rule that we're using there. So corresponding angles are equal. Perfect. And then this angle here, I know that this, if I do 180, take away 148. Now remember, more on the floor, borrow from next door. 10 take 8 is 2, 7 take 4 is 3. So this angle here is 32 degrees. What's the reason? Well, it's angles on a straight line add up to 180. And then last but not least, we can now look at that triangle at the top. So let's just highlight that for you guys. So that triangle here, we know that the angles in that triangle would need to add up to 180. So let's do 63 add 32, which is 95, and then 180 take away 95. Again, more on the floor, borrow from next door. 10 take 5 is 5. 7 take 9, I'm just going to borrow that one. 17 take 9 is 8. So there we go. X equals 85. And the final reason that I've used is because angles in a triangle add up to 180 degrees. Perfect. There we go. That is all of the reasons that I've used, and that would get me full marks, 5 marks for that one. So really well done if you got that. Question 27. The diagram shows a prism placed on a horizontal floor. The prism has a height of 3 and the volume is 18 meters cubed. Now, if you have a prism where you've got that cross section and then it goes back, that's what a prism does. You've got that same shape all the way through. To get the volume of that shape, it's the area of that cross section times by how far back it goes. So if they're telling me that the volume is 18, then I know that the area of that hexagon on the floor there, or at the top, however you want to look at it, the area of that must be 6, because they've multiplied it by how far back it goes or how long it is and got 18 meters cubed as their answer. So because they've times by 3, I know that the area of that cross section must be 6 meters squared. The pressure on the floor due to the prism is 75 newtons per meter squared. Work out the force, and we're given the formula up here. Now, pressure is all about the area of the face that is in contact with the floor. Okay, it's about that face that is touching the floor. That is going to be the pressure forcing down. So pressure is force divided by area, and you might remember it as a formula triangle like this: pressure, force, area. We're working out the force in this case. So if I cover that up and do the sum that's left behind, we need to do pressure multiplied by area. So the pressure, we're told, is 75. And the area we've just worked out, just the area that is in contact with the floor, is 6. So 75 times by 6. Now we don't have a calculator, so we're going to need to do that. Let's just do it up here. 75 times 6. 6 times 5 is 30, so 0, carry the 3. And 6 times 7 is 42. Add the 3 is 45. So our answer for that one is 450 newtons. Always be really wary about the units for these questions. So the pressure was in newtons per meter squared. Our area was in meters squared. And our force was in newtons. So everything matched up, and that's what we want to see. If it didn't, you might need to do some conversions to be able to get the right answer. Okay, question number 29. Given that A over B is 2 over 5 and B over C is 3 over 4, find the ratio A to B to C. Looks terrifying, but let's just write it differently. If A over B is 2 over 5, then the ratio A to B is 2 to 5. If B over C is 3 over 4, then the ratio B to C is 3 to 4. Now, if I want to combine these ratios and put them together, I really need the B's to be the same number. At the minute, I'm saying for every 2 of this, I've got 5 of these, and for every 3 of these, I've got 4 of these, which isn't very helpful when the B's are different. So I'm looking for a number that's in the 5 times table and the 3 times table, and that would be 15. You could go bigger, but you don't need to. Whatever you've done to this side, you need to do to the other side to keep this ratio equivalent. So I've times this by 3. I also want to times this by 3, and that's 6. With this ratio, I've multiplied that side by 5, so I also need to multiply this side by 5, and that is 20. And now that my B's are matching, I can say the ratio A to B to C is 6 to 15 to 20.
Question number 12, and we have a cumulative frequency graph. So the table gives information about the weekly wages of 80 people. So we've got our 80 people here, and the frequencies are shown. Complete the cumulative frequency table. So if something accumulates, it builds up. So if you have a look carefully at the headings here, if we just look at this first table, we've got 5 people who have a weekly wage between 200 and 250. We've got 10 people that have a weekly wage between 250 and 300. If you then compare that to the cumulative frequency, you'll notice the categories are different. The first category is the same, 200 to 250, so that's still got 5 people in it. But for the next category, 200 to 300, we're saying I want all the people in that first category, and I also want all the people in that category, so that all the people that earn between 200 and 300 are included. So that's going to be 15. The next class interval, the next category, goes from 200 to 350. So I now need to make sure these 20 people are also included. So we're going to add on 20, and that takes us up to 35. Then we're going to add another 20 for these people to get up to 400, and then that's going to be 55 people in that. And then we're adding 15, so that's going to take us up to 70. And then we've got 10 more, so that takes us up to 80. Now that bottom figure should be the total number of people. And because they told me there were 80 people, and I've got 80 there, I'm happy that that is correct. Okay, on the grid opposite, draw a cumulative frequency graph for your completed table. So we've got a few tables that we need to know about, a few graphs, sorry, that we need to know about. Cumulative frequency makes a smooth S-curve, and we plot at the top of the category for that. So we're going to plot at these values here. Frequency polygon, I often call it Polly the Shark. We've got this kind of shape happening, straight lines, and for that we plot in the middle of the category, okay? So don't confuse the two. Frequency polygon, you're going in the middle of the category, but for cumulative frequency, you go at the top of the category. So these are the values that we want to use here, okay? So that's going to make a smooth S-curve. A histogram, that's the one with bars, and that's, grade 7, 8, 9 kind of thing. So here we go. Right, let's plot those values. So I'll do it the best I can. Zoomed out, let's zoom in a little bit, across to 250 and up to 5, so that first value is going there, across to 300 and up to 15, across to 350 and up to 35, across to 400 and up to 55, across to 450 and up to 70, and across to 500, that top value, and up to 80, so that's going to go there we go. And then we're just going to join that up with a nice smooth curve. So I'll do my best on my iPad. You'll have to forgive me if it's slightly wonky, but there we go. There we go. You can take it to 0 or not. Doesn't matter if you do or don't with the cumulative frequency. Frequency polygon, don't ever take it to 0, but cumulative frequency, they don't mind on GCSE if you take it to the origin. There we go. So Juan says 60% of this group of people have a weekly wage of £360 or less. Is Juan correct? So 60% of the people, 360 or less. So let's go to £360 and let's use our straight line tool. 360 is there, 2 squares after 350. Read up, it's close. I'm going to go for 39 and go across. So I now know that 39 of these people earn less than that. And the rest of those people, so 41, because we know that there were 80 people altogether, 41 people earn more. Okay, so the question said 60% of this people have a weekly wage of 360 or less. Now, we've worked out 39 people earn 360 or less. Now, 60% of the 80 people, 10% would be 8. And so 60% would be 8 times 6, 48 people. So he said 60% of these people have a weekly wage of 360 or less, but that would need to be 48 people. So that's incorrect. So we would say Juan is incorrect. Oh, that's over the page, isn't it? Incorrect. There we go. Question number 14. Sally plays 2 games against Martin. In each game, Sally could win, draw or lose. In each game they play, the probability that Sally will win is 0.3. The probability that Sally will draw is 0.1. Work out the probability that Sally will win exactly one of the 2 games against Martin. So this is a tree diagram question. You do not need to draw the tree diagram, but many of you will find it helpful. So I've got three options. Sally is either going to win, draw, or lose. And then if she's played that game, she's going to play the game again no matter what. So she's going to win, draw, or lose, win, draw, or lose, and win, draw, or lose. So the reason I'm doing it 3 times is because if she wins, she's going to play again. If she draws, she's going to play again. And if she loses, she's going to play again. So we're just giving ourselves all of the right options. So win is 0.3. Draw is 0.1. We know that probability adds up to 1. So therefore the probability of her losing would be 0.6. And those probabilities are not going to change. It doesn't say that if she wins, she gets super confident and is more likely to win again. So we know that the probabilities are just the same. It says each time she plays, it's the same probability. So 0.3, 0.1, 0.6, 0.3, 0.1, 0.6. Fabulous. Now with a tree diagram, we times along the branches and then we add up the ones we want. In this situation, we are looking for the probability that Sally will win exactly one of the 2 games. So if she wins the first game, we don't want her to win again because that's not winning exactly one game. So we can win and then draw or win and then lose. I want both those options. If she draws, then I want her to win. And if she loses, then I want her to win. Those are all the options where she wins exactly one. So we times along the branches, 0.3 times 0.1 for that one, 0.3 times 0.6 for that one, 0.1 times 0.3 for that one, and 0.6 times 0.3 for that one. Now when you multiply decimals, however many numbers are after the decimal point will stay after the decimal point. So if you think about this first one, 3 times 1 is 3, but there are 2 numbers after the decimal point, so it would be 0.03. And the next one would be 0.18, the next one would be 0.03, and this one would also be 0.18. Adding all of those values together, I've got 0.42 as my final answer. So 0.03, add 0.18, add 0.03, add 0.18 is 0.42. That is the probability that she wins exactly one of the 2 games. Question number 16. Shirley wants to find an estimate for the number of bees in her hive. On Monday, she catches 90 of the bees. She puts a mark on each bee and returns them to her hive. On Tuesday, she catches 120 of the bees. She finds that 20 of them have been marked. Work out an estimate for the total number of bees in the hive. Now, this topic is capture-recapture, and it's quite a lot about animals and marking them and estimating how many are in the whole population. It's completely impossible to count all of the bees in a hive. They're going to move and you're not going to necessarily know how many there are. So she's just taking a sample. Now I would always do 2 fractions for this and I would make them equal because the proportion, we hope, is not going to change. So on Monday she catches 90 bees and marks them all. So that means 90 out of X are marked. And then on Tuesday when she catches 120, 20 of them are marked. So I'm going to say that the proportion of marked bees has not changed. On the first day, it's 90 out of X, and on the second day, or Tuesday, whatever, it's 20 out of 120. So that's not changed. Now, you could simplify that fraction. You can also multiply up like this, but I think the easiest way here is just going to be to say this is a 6th. So I'm going to say that 90 over X needs to equal 1 over 6. I've just simplified that fraction to be 1 over 6 by dividing by 20 on the top and the bottom. So what would that denominator need to be for that to be the same? Well, we've multiplied the numerator by 90 here, so I also need to multiply the denominator by 90, and that's going to be 540. So we would guess that there are 540 bees in the hive. There are lots and lots of different ways to do that. So ultimately you're just working with proportion. If you do it a different way and you get 540, that's all good, but that would be your answer. Shirley assumes that none of the marks have rubbed off between Monday and Tuesday. If Shirley's assumption is wrong, explain what effect this would have on your answer. Now, these are bees, these are live animals, so if we're marking them, there's quite a good chance some of them might have rubbed off. Now, I find it really hard to visualise which way this is going. So I personally find it a lot easier to use an example. So I like to use a number with this. Now, if on Tuesday she caught 120 bees and some of them had been rubbed off, and so it was 20, but it should have been higher. Let's just say, for example, that this should have been 60, but loads and loads had rubbed off. Then we'd be looking at a bigger proportion. So we'd be looking at half of the Bs should have been marked, and in which case there would actually only be 180 Bs in total. So if some of the marks had rubbed off, there would be less Bs, and that's all we need to say. So if Shelley's assumption is wrong, so if some of the marks had rubbed off, there would be less Bs in the population. So we would have overestimated. Hopefully that makes sense. So I find it easier to pick a number that makes sense. Pick a number that it could be instead, and then work it out again. That makes more sense to me. And then I can think about which way it's going. So if some of the marks had rubbed off, there'd be less Bs in the population, and we would have overestimated our answer. Fabulous. Question number 18. X is proportional to the root of y, where y is greater than 0. Y is increased by 44%. Work out percentage increase in x. This is tricky. So we want to start by saying x is proportional to root y. And we know that we can't solve equations with fish in them, so we'll change it to an equals and a k. That should always be your first step with proportionality. This is just proportional. It's not inversely proportional, so we're not doing that fraction. And when it says proportional, we're assuming direct proportion. So there we go. That's the first step. Now, if we make y 44% bigger, that is the same as timesing it by 1.44. So that would get us 144%. So I'm going to rewrite this as x equals k times root 1.44y. Now with square roots, we can split them up. So we can say that x equals k root 1.44 root y, and therefore x equals k root 1.2 root y. The square root of 1.44 is saying something times something that makes 1.44. We know that 12 times 12 is 144. So it makes sense that 1.2 times 1.2 is 1.44. So there we go. The square root of, I've still got a root in there. Sorry. The square root of 1.44 is 1.2. So there we go, 1.2, and that tells us that overall the percentage increase in x, well overall this value, if we make the number in the square root 1.44 times bigger, then we're going to make the value on the outside 1.2 times bigger, and timesing by 1.2 is the same as getting 120%, and therefore it's a 20% percentage increase. Very tricky. Question number 20. Show that root 180 minus 2 root 5 over 5 root 5 minus 5 can be written in the form a plus root 5 over b, where a and b are integers. So this is surds, and we are rationalizing. When you rationalize, you're getting rid of any surds from the bottom of the fraction. And sometimes we can do that. If it was just something like this, then we would times by root 5 on the top and root 5 on the bottom. And that would get us 3 root 5 over root 25, or just 5. So to get rid of a surd, you can times it by itself, and then it just becomes the integer. But that doesn't work in this situation because we've got 2 terms on the bottom of the fraction. So I'm going to start by writing this out again. And what we're going to do, instead of timesing it by itself, we're going to times by something called the conjugate, which is the opposite. So if I've got 5 root 5 minus 5 on the bottom, I'm going to times by 5 root 5 plus 5. And what that does is it does a little bit like the difference of 2 squares. It gets rid of any middle terms. Now when we're timesing 2 terms by 2 terms, it's much easier if you put brackets around that. So let's look at this denominator first. 5 root 5 times 5 root 5 is going to be 25 times 5. 5 times 5 is 25, and root 5 times root 5 is 5. And then I've got plus 25 root 5 minus 25 root 5. And we wanted that to happen because they are going to cancel out and get rid of any surd terms. And then last but not least, I've got minus 5 times 5, which is minus 25. So therefore, your denominator is 125 for that bit, 25 times 5. Take away 25, which is just 100. So my new denominator is 100. Now let's look at the numerator. I've got, I think I would simplify this first actually. The square root of 180 has a square number that goes into it. It is root 36 root 5, which is 6 root 5. So I'm actually going to simplify that first. 36 is the biggest square number that goes into it, so we can rewrite it as root 36 root 5. If that's tricky, then go back and revise simplifying surds. That's kind of the level before this rationalizing stage. So I've got 6 root 5 times 5 root 5, and that is 30 times 5, because I've got 6 root 5 times 5 root 5. Then I'm doing 6 root 5 times 5, which is 30 root 5. Then I've got minus 2 root 5 times 5 root 5, which is minus 10 times 5. And then I've got minus 2 root 5 times 5, which is minus 10 root 5. So altogether, I've got 150, and I've got minus 50, and then I've got 30 root 5 minus 10 root 5, which is 20 root 5. So that is 100, add 20 root 5 altogether. There we go. Now they've asked me to make that in this format, which means that we're going to take that big fraction and split it into two parts. So it's 100 over 100, add 20 root 5 over 100, which is going to be 1, add, and then this one we can divide by 20 top and bottom, root 5 over 5. And now it's in the format that they asked for it. Okay, very, very tricky version of rationalising surds there. So if that is something that you find challenging, rationalising surds is the topic there, particularly with two terms on the bottom like that one had. Question number 22. The diagram shows two shaded shapes, A and B. Shape A is formed by removing a sector of a circle with radius 3x minus 1 from a sector of a circle with radius 5x minus 1. And shape B is a circle of diameter 2 minus 2x. The area of A is equal to the area of B. Find the value of x. Okay, so let's start by getting expressions for both. This one's probably the easiest, the circle. So I'm going to start by saying pi r squared is the area of this, and the radius would only be from the middle to the edge. So that's going to be half of what we've got here. So 1 minus x is going to be your radius. So let me put in equals, because I'm going to do the area of A equals the area of B. So the area of B is pi times 1 minus x squared. That's the area of that one. Now let's do the area of A. Now, 45 degrees out of 360 is an eighth. So I'm actually just going to I'm going to imagine that the whole circle is there, and then I'm just going to divide my answer by 8 at the end. I think that's going to be easier, rather than doing, you can write 45 out of 360, but we haven't got a calculator here, so I think it's going to be easier to divide by 8. So I want to do pi times 5x minus 1 squared minus pi times 3x minus 1 squared, all divided by 8. So that would be the area of the whole circle with a radius of 5x minus 1, because that's from the middle to the edge, all of that added up. Take away the area of that middle bit, and then I'm dividing by 8 because I only want that one section out of 8. Okay, now everything has got pi in it, so the first thing I'm going to do is divide everything by pi. That's quite nice. Then I'm going to multiply out these brackets. So I've got 5x minus 1, and remember, when you're squaring a bracket, you're timesing it by itself, so write it out twice. So that's 25x squared minus 5x, add 1, minus, and then I've got 3x minus 1 times 3x minus 1, and this is all being subtracted, so please, please, please keep it in brackets. So I've got 9x squared minus 3x, add 1, equals, and then over here I've just got 1 minus x times 1 minus x, which would be 1 minus x, add x squared, and that add is coming from the fact that we're doing a negative times a negative, but remembering that this is all over 8. So now let's simplify, and I want to multiply both sides by 8 as well. So I'm going to times this side by 8, which will get rid of that denominator, and then I'll need to times this side by 8. So let's have a look. I've got 25x squared take away 9x squared. This term take away this term. So that leaves me with 16x squared. I've also got minus 10x here, but I'm adding, because I've got minus 6x here in total, but I'm minusing minus 6x, which means I'm going to add it. So I've got minus 10x from here, add 6x, which is minus 4x, and then I've got 1 from here, minus 1, which is gone. Okay, now that is over 8, but we're going to times both sides by 8, so we're going to get rid of that, and we're going to instead times everything on the right-hand side by 8 to get rid of the denominator on the left. So that is 8 minus, at the minute I've got minus 2x, so timesing everything by 8 is going to give me minus 16x, and then add 8x squared. And we've got a quadratic, we want to make it equal 0, so I'm going to take 8x squared away from both sides. So 8x squared, and I'm going to add the 16x to get rid of this, which makes it plus 12x, and then I'm going to take away 8 from both sides, equals 0. Okay, all of those terms are in the 4 times table, so I'm going to make my life a little bit easier here and divide both sides of this equation by 4. So 2x squared, add 3x, minus 2 equals 0. Now that is going to factorise, we would hope, on the non-calculator paper. Sometimes it doesn't, but most of the time it does. So we were looking for 1 and 2, so I'm going to pop the 2 here and the 1 here, because that's going to give me 4x and 1x, and that's going to enable me to make the 3x in the middle there. So positive 4x, take away the 1, and now I just want to look, when would each bracket equal 0? So to make 2x minus 1 equal 0, 2x would need to equal 1, and x would need to equal a half. And for this bracket, if x add 2 needs to equal 0, then x just needs to equal minus 2. Now that doesn't make sense in the context of the question. We can't have a negative length, so we're going to disregard that solution and say that our answer is a half, this one over here.
Hopefully that made sense and you were able to follow along. I hope you found it helpful. Let me know in the comments if you've got any questions at all, and I would love to help you. Thank you for watching, and I will see you guys next week for week 15.